Thanks, Mitch. This is really an exciting project. The conversation all started with one of our former board member, Ty Linkhorst, serving our advisory board. As we talk about opportunities to, collaborate and how UMSL talent of our faculty and students can help to support Ameren, conversations start there. So this is a outline of our presentation. We'll start with some introduction background. We'll describe the problem descriptively with what the data needed, and we'll describe the research approach, conceptually describe the model we use, and present you the solutions. We'll wrap up.
Thank you, Tom. So just to give everybody a little background on Ameren and what we do. So we are an electric and gas utility provider. We have about 2.5 million electric customers and 900,000 gas customers. This is a difficult maneuver. All right. Louder? All right. So we also operate as 4 different companies, which might be kind of unique to everyone as well. So we have an Ameren, Illinois company, an Ameren, Missouri company, then Ameren Transmission, which does the 345, the major transmission lines, as well as Ameren Services, which is all your shared organizations like HR, digital, and supply chain. So there's a kind of visual later that'll help conceptualize this, but we operate mainly in a hub and spoke model. We have to operate as 2 different entities, so that'll come into play later. Ameren, Illinois cannot ship material to Ameren, Missouri. Ameren, Missouri can ship material to Ameren, Illinois because we're a regulated entity. One organization doesn't want to be seen as subsidizing the other, so that was kind of unique. So let's go to the next slide and give a little bit more of an overview of our supply chain. So we have about $350 million of inventory. A lot of that is in safety stock and kind of we have to be prepared for major storms. We have generation as well, which needs a lot of material. So we'll get into it later, but a lot of this initiative was not to minimize our stock. It was to how do we get material from point A to point B most efficiently within our current network. So Ameren, Illinois, as I kind of alluded to, has 1 stocking location. Ameren, Missouri has a few major warehouses that then service what we call operating centers. And think of operating centers as kind of your local community hubs that linemen show up to. There's some material there for them to do their projects and maintenance work, and then they service their local communities. And then Ameren Transmission, we left out a scope of this because we use a third-party integrator for them. They do major projects all across the region. We don't really store their material in our warehouses. So Hightail kind of touched on this, why we're here today, and it sounds like most companies are doing kind of transformation initiatives. We did a study 3 years ago. Supply chain was kind of an underfunded organization at Ameren, and we took a step back, and they pulled several of us out of supply chain and put us on a full-time team to build a business case, build a roadmap, build a plan, and we broke it down into several areas: simple buying, smart buying, reliable supply, and materials and services planning. And one of the initiatives that kind of fell under reliable supply was, do we even have the right network? Go back, our network is largely kind of due to acquisitions. Everybody kind of kept their own regions, even though we acquired multiple companies and became Ameren, Illinois, and Ameren, Missouri. So there's some inefficiencies in how we deliver materials, but we didn't know what the right way was to do that, and we definitely didn't know what the benefit financially was to do that. So that was kind of the goal of this initiative. So here's just a kind of an overview, and you can see the maps of Ameren, Missouri, and Ameren, Illinois, and we don't deliver directly to and drive back. We do milk runs, but this is just trying to help conceptualize where the locations are at. I think it's important to note, too, that we may not be the largest utility, but we have a very broad geographical range. We service a lot of the local communities that may not be massive hubs like St. Louis. They may be smaller towns like a Belleville or Edwardsville or Marion down in Illinois. But we drive a lot to get material from point A to point B. So our goal was to figure out how do we drive less. And then there's a map of the model up at the front. We do some direct delivery and job site, but we were focusing on what we'll kind of refer to as tier 1, tier 2, and tier 3. How do we best optimize that? How do we get material from our suppliers from point A to point B? So here is kind of what Mitch talked about, the translation. We had abundance of data that didn't really make any sense, that were sitting in different ERP systems because we have a combination of, we use a different inventory system than our purchasing system. So we were able to extract 3 years of demand data, which helps us understand what the volume was through the network. supplier delivery costs, Ameren pick, pack, and receive times. And this was really great. And I can't thank Mitch and Hightower enough. We didn't have a lot of this data. So we had to go out and talk with stakeholders, understand what data we needed to even capture. And Mitch brought a lot of real world expertise. Hightower brought a lot of, here's what we need to develop an effective model. So we were trying to get a lot of that knowledge out of our employees on how do we actually understand our cost to serve. That's another thing, a good byproduct of this is we knew what our burden cost was. We had no idea when you break it down into logistics and receiving, packing, and things of that. We had no idea where those were at in our supply chain, so that helped us understand that as well. And then mileage cost, we use a third-party logistics company in Illinois for some locations. We do internal deliveries for other locations, and then vendor lead times, fixed variable cost by location. And one that was really interesting that I think helped us get to a real world solution, which is pallet equivalent units. So we built some, I don't know if you want to call them bumpers or in the model that basically said, hey, you can't ship 1,000 poles. That's not going to fit on a truck. So we took our product categories, poles, wire and cable, transformers, MRO, safety, all of those things, and kind of put a conversion to them that, hey, on average, you can fit 0.1 pole on a pallet, or you can fit 1,000 safety items on a pallet. And then we put capacity in for, all right, a typical semi can have 24 pallets or 48. I don't remember what the exact number was. And then also did that by location. So each location has a certain amount of yard space and warehouse space, and how much material can we store there to minimize shipping. So that was a really difficult one, but a fun one and an effective one that really helped us get to, I think, some real world solutions out of the model. So I think I got one more, and I'm going to make sure I'm staying on time here. We broke it down into a couple areas, and I think what was nice about this model approach too is, like I said, we knew our burden costs at a very high level. We had no idea how that was made up. So we built the model from the ground up using transaction times by product category code, and then broke it into several buckets on inbound, handling, outbound, and then overhead costs. And you can kind of see that there's handling at multiple locations. You'll see when we get into the model. We do some things where we'll deliver to a central warehouse, deliver to another operating center, that then deliver to another operating center. So we have handling costs kind of throughout the supply chain. And then you'll notice we also left pick pack off of the end nodes because that's actually what the linemen, they come in and grab the material for the day. So we were really just looking at supply chain costs for this model. I think that may be my last slide. So I'll hand it over to Hightower, and he'll get a little more into the technical side of the model and some of the key research questions.
Thanks, Logan. Sure. As you can see, Ameren is operating a fairly complex supply network in terms of number of locations, facilities, as well as the number of product categories, items, raw materials, equipments, parts. So the good news is, however, we're not starting from scratch. They already have a well-established hub and spoke network, as we showed earlier, right here. But this graph, what this graph does not show is the complexity, because now realizing that for each category, such hub-spoke relationship can vary. Okay, so we were able to categorize all the parts, materials, items managed at Ameren into about 56 categories. Okay, that's more of an aggregate approach to make the problem manageable. So what are the key research questions? The key questions is to exploit the potential benefit of using a location pooling, right? So many of you know, if we pool the demand all together, there is going to be tremendous savings potential on safety stock inventory. But on the other hand, since now it's more centralized operation, potentially transportation costs will increase. Now, what is the best? What is the optimal number of stocking location and where? That's the central questions to exploit. Well, experts like Logan and Ameren had some managerial idea, expert opinions or hypotheses, but without data, without analytics, it is really hard to achieve that sweet point. That is exactly what our focus is. And of course, through our study, we also conducted the so-called what-if analysis to provide some playbook that Ameren management can really use to figure out what to do under certain catastrophic scenarios. So this is a high-level description of our research approach, like Logan briefly mentioned. From the very beginning, we work very, very closely. Okay? From the very first step, defining the problem scope, the definition of the project, and collecting the data. And you can see each of these steps, we go back and forth, okay? So this is not a linear approach, right? Yeah, you do one after another, boom, that's not no. This is always iterative, and sometimes, you can call it frustrating or not, but it's not really frustrating, but we have to go back, even at the point we do model validation, which is a very, important step, which is a very important step. Then we realize there are some issues to be handled, okay? We need to better define the problem more precisely. For example, at that point, we understand Ameren does not need to open new locations, okay? But what we're doing here is mainly selecting the existing facility as stocking location. We also spend quite a lot of time at this stage try to validate our optimization model such that it generates numbers and results that is at the equivalent scale of Ameren's current spreadsheet approach. This is a very important step. Before we go to the next one, that's the step we probably spend 4 or 5 months on that, going back and forth. All right. So let me describe conceptually what the model is about. Essentially, we're optimizing the location of stocking location, okay? The selection of stocking locations for Ameren supply network. And this decision is made for multiple categories, product categories, up to 56. And we look at within Missouri and Illinois, up to about total together over 100 locations. And the model also considers the cycle inventory decision as well as the safety stock decision. And in the second phase of the project, although today we focus mainly on first phase, in the second phase, we're looking into more on the supply side disruption, which is very relevant nowadays. Just by looking at the recent hurricanes in Texas and many other places. We did scenario analysis, okay? So the decision is to determine which facility to be the stocking location, and if they are selected, their assignment, okay? Which of the operating center they should serve. And again, that relationship may vary by product category. That's what makes the problem really, really complex. And again, we also optimize the reorder point in terms of the inventory and safety stock, okay? Yeah, at each stocking location. So the model will optimize the total supply chain cost as its objective, which consists of multiple cost components, okay? First one is the fixed setup cost or simply fixed operating cost of operating a stocking location. And then we certainly consider the variable logistic and transportation cost, which is a very important piece. And inbound ordering cost, okay, that's kind of fixed cost per order, safety holding cost, okay, as well as the inventory handling cost. So it's quite comprehensive objective. We try to minimize that. And the model will incorporate a number of constraints, okay, we call it constraints, but they are in general sometimes requirements, sometimes limits, sometimes business rules, right, that must be satisfied in this implementable solution. For example, for each facility, we are able to choose their best capacity option, okay? Yeah, you can have low, medium, high. Yeah, for each product categories, there are some business rules, right? Yeah, for example, tier 3 operating center cannot be served by a certain tier 2 operating center. And certain product category cannot be shipped directly from the supplier, okay? Those are more of the business rules that we need to satisfy. And there are certainly some other constraints needed to represent mathematically the amount of safety stock. Okay? Now, I'm not going to get into the technical details of the model. The model is, I can tell you, it is a mixed integer nonlinear programming model. The nonlinearity need for that comes from representation of the safety stock, okay? Yeah, so you can imagine the square root, right? Some square root of, lead time, you compute the safety stock. that is an added complexity on top of the combinatorial nature of the problem, because the number of selection options for stocking location is combinatorial, right? It grows exponentially with respect to the size of the problem. It is challenging. We were able to implement a transformation technique to convert, to reduce the original model to one that's more manageable, okay? So the one we reduced to is the so-called quadratic programming model, which is much easier to solve, okay? We do use state-of-the-art solver to get our solutions. Okay, back to Logan. Yeah.
Yes, I know. He's way louder than I am. I'll try to yell a little bit. He's real excited. All right, I could do that. So I know we're a little bit of time, so I'll kind of go through this, but some of the results, here's just an overview of a Visio flow of kind of one of our networks in Missouri currently. And then you can see what's important here is the yellow. So this is where we'll deliver to a warehouse that'll deliver to another operating center that then the business line loads up and delivers to another operating center on their truck. We knew that wasn't efficient. We just have never really taken a look at it and understand what the benefits are. And it's, I think, an important note of this model is some of the key stakeholders that helped us build it said, yeah, that makes sense. I've kind of thought about that all along, but we've never had the data to back it up. Here's the actual benefit of it. So it was actually really good to see what they thought was best kind of visualize itself in the model. So here's just an example of what we should look like. And what this is supply chain actually takes real ownership of delivering materials from point A to point B. Take that burden off our business line. They don't have to do it. We'll include it into our milk runs out of our central warehouses. So I'll go kind of quickly to, I think, some of the scenarios, because I think that's a little more interesting and a good byproduct. So this is, Hightower touched on this briefly. After we built this, we were able to actually start asking some questions that we've always wanted to know. Hey, what if one of our warehouses went down to an earthquake, tornado? At one point, we were really worried about COVID outbreaks, that we were going to have to deliver material elsewhere. We didn't know what to do, and that was a risk. So now we were able to ask that question to the model. It was able to say, hey, all right, your central warehouse is done. These operating centers can take on additional capacity, have your suppliers deliver there. Then here's your network from there. And that's allowing us to now put really good plans in place. We've touched base with digital stakeholders. How do we update our ERP system to notify these changes to our suppliers that, hey, you're not delivering to Dorset anymore. You're delivering to River Mines or Underground or St. Charles. As well as, all right, we move these vehicles here, we move these people here. We're really putting good business continuity plans in place as a result of this. And we played with some other scenarios on, hey, if shipping costs were to go up or down, is there any way to capture some of that benefit? Is there any way to offset some of that increase? So it really gave us a good playbook for different scenarios. And one that we've always, I'm sure Mitch and Hightower have heard this, Ty's big thing was, how do we get out of the mops and buckets games? We want to store transformers, poles, wire, and cable. I don't want to be storing a bug spray, hand sanitizer, sunscreen, things that the linemen still need, but we store through our central warehouses. And we were able to model it. Hey, right now there's no benefit. Your cost to deliver that from your supplier is too high. You're going to these locations anyway. So we were able to give that to the category manager and say, hey, if you can get these costs down, then there's a benefit to do that. It frees up space in the warehouses. We can get it directly to our end customers. So it really allowed us to start having good discussions with all stakeholders. And I think there's really only one more slide. So hand it over to you, or is this me? Me? Okay. So some conclusions and takeaways. So we did identify savings on actually making some of these changes. We can minimize the miles we drive. We can there's some efficiency savings in there that we can now use those efficiencies to do other things. Kitting is something we really want to look at. The big one was data-driven business insights. I think most cultures at most companies now is show me the data behind it, show me the benefit. And that's something we had no access to before. So that was a huge benefit for us. We could actually start having discussions to the numbers. And then the joint effort, I can't thank Hightower much enough. It took us a long time to develop this, and I'm glad it did. They really sat down and made sure we did it right. They didn't come in and try to burn through something in 8 and 10 weeks. It took us well over a year and 6 months just to even get the data and translate it. And they were able to bring real world insights as well as academic research and really give us a viable solution. So thank you for that. And I think we're done. Questions.
I just have one comment to make about the last point. I think the joint effort really is the key. Yeah, from the very beginning. That's the approach we make sure the problem we try to solve, the model we build, right, actually help the company, okay, actually deliver the impact. Yeah, So we're open to any questions you may have. Yes, Masa. Yes, yes, I will. Masao asked an excellent question. The model seems to minimize the total operating cost. The question was whether we should also minimize the number of lost service, right? Disruption of service. Yeah. So metrics on the service side. Yes, definitely. One component of the model is what we call service level. Okay. By computing the amount of safety stock, and given the target service level for Ameren, service level is really high. We use the numbers up to 98%. Because for Ameren, it's crucial for them to make sure they keep enough inventory. So in this model, that is the component we take care of the service side. We make sure, on average, right, in an inventory cycle, Ameren is able to keep enough inventory, in their supply network. But to address, Masao, your question down to the more operational level, because I can see your question actually address may have to do with more operational level of issues. Let's say you have some outage going on, right? We have this service area to cover. How should Ameren dispatch their operators, their technicians? That's going to be a question to be tackled at a more operational level. It will be a somewhat different model. So it's going to involve more detailed routing, right? How do you route? How do you schedule? Your technicians and routing of the materials. But right now, this model is more at the strategic level. Yes, Chris.
So this one is largely implementing this. Oh yeah. Core transformational. What has to happen in order to achieve this? I think is kind of a summary of it. A big one for us is roles and responsibilities. We have a pretty robust labor landscape that has pretty clear defined roles and responsibilities, and we purposely kind of didn't include those in the model because we wanted to know what optimal was. So there's a long-term roadmap, and we didn't put a lot of things in here like, did it have a receiving dock? So there's facility things that need to be included as well. So we're actually working with our facilities group, and hey, as these locations come for upgrade, we need to put a receiving dock in there so they can get shipments from our central warehouse instead of a pickup truck. So I think the big one is roles and responsibilities of certain employees as well as the facilities that need to be upgraded in order to achieve this as well. Yeah. Yeah. I mean, it's yeah. So Ameren, yeah, labor agreement landscape. So Ameren, Illinois had an acquisition, and pre my time, let's just say 10 plus years ago, where there were several operating companies that then merged into Ameren, Illinois, and you could see that not necessarily in the visual I had earlier, but when we mapped out it, we were not segmented geographically in the best way possible. It was segmented by what operating company delivered to what. So those are the kind of existing labor landscapes that we have that we need to really think through, and how do we best design it in order to get material from point A to point B. So I've used a frame where a network through osmosis, just slowly it kind of happened. We never took a holistic approach after we made these acquisitions in the past, and so that's something that we need to really think about. That's a really long-term plan for us, but it's something that we can actually start thinking about and planning for. I'll hand that over to Haito.
Yeah, all the model development and computation and the analysis were performed at UMSL. Yes. But we, again, without the collaborative efforts, we would not have developed a model that's truly, have the real world impact. Yes.
Yeah. So one is the long-term planning. We're making sure that the stakeholders and oh, yeah. So what is your long-term plan for implementing this model moving forward? And that's exactly kind of what it's a plan that we can now set goals for some of the supervisors in Illinois, the supervisors in Missouri, kind of the directors over operations to say, hey, here's a 5, 10, maybe even 15-year roadmap in some instances. That's one of the big outcomes is now we actually have a direction that we want to head and reasons we want to do certain things in order to achieve the benefits of the business case or the model. Another one is the business continuity planning. And those are, I mean, at a very high level, we could say deliver this material to this location if something were to go down, but that's not really going to be effective in a scrambling situation. So we're really developing better business continuity plans on if there were disruption, who moves where, how do we notify suppliers, how do we update our systems, what vehicles move where, make sure all the stakeholders are notified, hey, don't call MDF, you call this location. So we're able to put some playbooks together on disruption as well as category management, like we alluded to. We wanted to do direct delivery for MRO. We didn't want to be stocking certain things in our central warehouses. So now we can get in touch with the category managers over that and, hey, you need to work on getting delivery costs down or work on direct delivery. Here's the benefit of that. And then Hightail can probably talk to phase 2. I think that's really going to help us as well from a supply disruption that we're, I think, all experiencing now with lead times going up. It's just giving us really good data-driven playbooks for our supply chain individuals.